Welcome to Study Loop.
Hi, here in this given problem, initially the person was at the top of the hill. Suppose the height of the hill above the water level, that is h. Now he swings down the first path through which he can touch the water, that is shown here, and this is the second path following which he can touch the water. This is path 2. Suppose height of this path 2 above the water level, that is h. Now velocity of the person while touching the water level following path 1, v1, that is given as 13.0 meter per second, with which he enters the water. So using energy conservation here, as he starts from rest at the cliff, at the top of the cliff, so here it will be gravitational potential energy only if m is the mass of the person, and at the water level it will convert into kinetic energy, half mv1 square, cancelling this m. Height h will be given by v1 square by 2g. So for v1, this is square of 13 divided by 2 times 9.8, and it is calculated to be equal to 8.62 meter. So now height of the person above the water at path 2, this is given as h is equal to 5.20 meter. So we have to find the speed of the person as he leaves the rope. So using energy conservation again, at the top of the cliff, and when he leaves the rope at path 2, it says initial gravitational potential energy at the top of the cliff, mgh, that will be equal to gravitational potential energy at the point where he leaves the rope along path 2, and kinetic energy there, half mv2 square, cancelling mass from both the sides again, we get an expression for v2, and that is the square root of 2g h minus h. Plugging in the known values, this is 2 times of 9.8 multiplied by 8.62, which already we have found, minus 5.20. So finally this v2 is calculated to be equal to 8.19 meter per second, which is the answer for this given problem here. Thank you.